Hello guys, welcome back. Today we are going to start today little question. So let's continue. So today we have 1318 questions and we have to find the minimum flips to do the you can say A or B equals to C we have to do. Okay, we have to focus on this one and this one. Okay, so minimum flips we have to do and we have to make this to C, and this question has been asked in Microsoft multiple times. So make sure that if you are appearing for Microsoft interview, you should have little hands on this one. Okay, so question is saying that we have given three positive numbers, right? That is A, B and C, and we have to return the minimum flips required in some bits of A and B that will make A or B is equal to C. Okay, that is called bitwise operation, right? Now it is saying that flip operation consists of change any bit, a single bit, you can say 1 to 0 or 0 to 1, okay, in the binary representation. Let's suppose example we have given here 0 0 1 0 representing A. So this will this will become what? 0 0 0, because 1 0 is 0 1. So this, and there is 1 1 1 0 B, and that represents to 0 1 0 0, like this. Okay, if we'll do the you can say or, right, of A and B, so 0 1 0 1 is C. After doing the sum, this will become C. If A or B is becoming C, this is the example saying. Let's suppose we have A equal to 2, B equal to C. If we will do OR with respect to the change of one bit is equal to C. So how we'll do the flip? So A we have 1, B have what? 4. Let's suppose. Now C will become what? 5, because A or B is what? C, right? Similarly, if we'll do A equal to 4, B equal to 2, C equal to 7, right? So how many flips will happen, right? So we have to make what? No, just one we have to add, right, in the place of there, right? So A is, let's suppose we have 4, so B will become what? 3, right? So now C will become 7. Like that we have to do. Okay, so before understanding these questions, right, and going through the all the bits, right, in this way, right, there is no number of flips is required. What here? A, B, if you'll do OR, it will become C. Let's suppose, just for example, plus, if we'll do plus, right, this is OR, right, so it will become equal. Number of required is no, there is no number of required flips. This is already done. So the question it is saying that we can do if you have awareness of bit representation, right? Let's suppose if you are not aware of the bit manipulation, right, if you have little bit idea, then it's okay. If you don't have, let's get a brief idea about how does it look in some basic bitwise operations, right? Let's understand the bitwise operator, right? So bit manipulation is very important in for the higher level of programming and interview. It is an act of manipulating bits, like changing bits of an integer. At the heart of the bit manipulations are the bitwise operator, right? So let's suppose we have NOR, right? NOR is the questions, right? You already aware of this signal, right? So NOT is operations, right? So bitwise operator, NOT is unary operator, and that flips the bit of number if the number of bits is 0, and it will change it to 1. Vice versa, we can say that, right? So n, let's suppose n we have equal to 5. So if you represent in you can say binary, it will become 101. Remember, I think 8421 is the formula, right? So if we have n equal to 5, n equal to 5, so how we'll do the 5, right? So this will become what? 1. This will become, sorry, and this will become what, 1. Rest of the thing is 0, right? Because 4 and 1 is 5, right? So this is your representation, okay, of you can say a binary, correct? So this is the binary representation, and if we will take this value of not, right? So if we'll do not, means the 0 will be, if we'll make the not, right, this is 1, right? So this will become what, 0. This is 1, this is 0, this will become 1. This is what, 1, then we become 0, right? And this will become what, 1. But we are not considering this one because only 3 places we have to count, and this will become your value, right? For 0 to 9 element, we have to consider only these 3 element, right? So we will not count this one. So this is your value, okay? And that's why you can see here it is coming like this. So now if we'll do the sum in the 8421, let's check. So this value is only 2, right? So this is your 2, okay? You understand, right? Now if we'll come to AND operator, right? That was a NOT operator. Now let's suppose AND operator in bitwise, and if both bits we are going to compare of the bit pattern are, let's suppose 1, the bit is resulting in the pattern is 1, otherwise it is 0. So we already know about the how do we represent element into a binary, right? A number into binary, that is look like this one. If we'll do AND, right? So here what we have, for 1 0 1 we have, and we have 0 0 1, okay? And we have to do AND, right? Once we are going to do 1, so 1 1 is, it will become what, 1. 0 0 will become what, 0. And there is 1 0, right? So 1 0 is also 0, okay? So that's why this will become 0 0 1, and this will become what, that is from 8 4 to 1, this is the 0 0 1, right? So this is 1, it is coming from here, right? So value will become 1, okay? And that's why it is coming 1, okay? Now coming to OR, right? So let's suppose we have a bitwise OR, right? And it is similar to the AND operator that we have done. If both bits in the compared position of pattern are 0, right, the resulting bit pattern is 0, otherwise 1. So 5 we have what, 1 0 1, and 1 we have what, 0 0 1, okay? So what we have to do, if 1 1 are same, right, both pattern are same, then we will take 1. If 0 0 is there, so this will become 0. But if 1 0 is there, any place is 1, then we will mark as 1, okay? So if we consider this one 8 4 2 1, right? So this is 1 and this is 1 0. So this will look like what, 5. We will take 4 plus 1 and it will become 5, right? And that's why it is coming 5, okay? So now you are capable of understanding NOT and OR. Now we are going to understand JOR and bitwise OR if bits are 0 and 1. So the results will be 0, otherwise 1, okay? So if we'll consider 1 0 1 and 0 0 1, okay? So if we'll mark if this is OR, right, so we have to consider like this, right? This is the JOR operations, okay? So if we'll consider JOR, then 1 1 will become what, 0. 0 0 will become 0, and any of 1 or 0 is different, that will become 1. And from the 8 4 2 1 formula, this is nothing but what, we are not going to consider this one, leave it for now. And this is only for 4, right? Because rest of the is 0 0, okay? So that's the reason it is coming 4. In the left shift operator, right, what we have to understand, left shift operator is binary operator, which shifts some number of bits to the left and append 0 at the end, right? So one left shift is you can say equivalent to multiplying the bit pattern with 2, okay? So if we have 1 is let's suppose we have what, 1 0 0 1, let's suppose 0 0 1 we have, okay? And if we'll do the left shift of one operator, let's suppose we are taking like this, okay? So now this value will become what, one shift we are taking, so this will become 0 1 0, okay, in the decimal. because we are taking one shift, okay? And if we'll take the again one shift, means two shift we will take, let's suppose for the for here, right? So this will become here 1, so now it will become what, 1 0 0, okay? And this is nothing but our 4, right? From 4 to 1, from 4 to 1, this is 1 and rest of are 0, so this is 4, okay? Now so you have understand, right, what we have to do. The left shift operator of binary, we shift some number of bits to the left and append 0 at the end, right? This is the meaning, okay? So if you are doing 1, means we are doing appending 1, right? So what we have to do, actually what we are doing here, we are doing appending 1 here, okay, in the left side. So 1 1 becoming what, 0, right? The next what we have, you have 1 in carry in hand, so it is becoming what, 0, and this 1 is what, 1, okay? And at the end 0 is 0, so we will put 0 is 0. So in this fashion we have to do the carry. Again from the 2 shift, now this is the we are going to add one more, so we will add here, where, here, after the 2, right? So 0 will become 0, 1 1 is 0, but after this 0 there is one more 1 is there, right, as a carry, right? We have to take it, so this will become 1, okay? In this way we are doing left shift operator. Similarly for the right shift operator, what we have to do, right shift operator is a binary shift in which some bits to the right append 0 at the left side, or one shift is equivalent to dividing by the bit pattern with the 2. Means let's suppose we have 1 0 0 we have given, okay, and we have to do what, one shift, okay, right shift we have to do. So in this case what we will do, let's suppose in the right side we'll take here 1, we are taking right shift 1, we will add, so 1 1 what become, it become 0, correct? And this 0 and this you can say 1 1 0, and then what we have to do, we have to take one carry, so this carry and this 0 will become what, 1, sorry, become what, 1, and this 0 is 0. Similarly we'll take for the 2 shift we'll take 1 here, and what will happen, we'll take this will become 0, and this is 1 1 is 0, but this 0 and this one carry will become what, 1. So here is 2 shift, right? It will work like this, and this is the value you are getting now, right? Now if we'll do any shift of this 3 shift, let's suppose, so we have, if third shift is coming, let's suppose like this it is coming, so we will take one value here, right? And what we'll do, 0 0 and 1 1 is 0, so there is no any element right here to make this carry, so you will lost one carry here, okay, right? But if you want to continue this one, right, that's a different thing, okay? So in this way you will find your value, right, and you will say this is equivalent to 0, okay? Now think about yeah, so we have covered everything, like we have covered NOT, NOT, AND, OR, JOR, left shift, right shift, okay? So these all things are you can say in the bit manipulations, right? So and it acts as a bit, right? So if you want to change the bit into something NOT or AND or JOR, left shift, right shift, so you have to take care of little things to understand, okay? Now coming back to our problem, right? So this was the problem that we have to take the minimum flips and we have to make A or B, right? So we are talking about OR, right? So you have already seen the OR, right? What we have to do for this one, if 1 1 are 1, we will take 1. If 0 0 is 0, we will take 0. 1 0 is 1, right? It will look like this one, okay? So in this way we have to do the bit manipulations, right? The first approach we are going to understand here is the bit manipulations. So in the bit manipulations, what we have to take care of, that we are going to see. So for example, let's suppose we have given this one this bit manipulations approach, right? And to understand that, we will determine the minimum number of bit that is required. Let's suppose we have A and B, okay? And we have to achieve what? We have to achieve the bitwise or, let's suppose bitwise or, okay, we have to achieve, and that will be equal to, sorry, that will be equal to, it is going, I don't know what happened, that is equal to, you can say, C, okay, like this. So we can manipulate each bit of A and B, and this can be implemented by iterating over the bits of numbers from the least significant, the rightmost bit, of the most significant leftmost bit, right, that we have already seen, right? Okay, so let's suppose during the iteration, right, we have to obtain some significant value. Let's suppose some value, right, let's suppose some value, as I'm saying, we are taking P, okay, so we are going to find some bit of P, and we can use the bit AND operator with this one, so it will look like this one. So purpose here is to obtain the bit, we are going to obtain this bitwise operator, right, and we are finding our significant value of P, okay. So during the iteration, we keep track of the answer, right, and the number of bit flips that is required in A and B. So for each bit position, we need to consider two cases, right? So first, either we'll say some value we have, right? So let's suppose we have a case in which what we will do, we are going to do what, C and 1, that is equal to 1. So in this case, we need at least one bit of 1 in either A of 1, right, let's suppose A of 1 and B of 1, okay, like this. So if either of A of 1 and B of 1 is 1, if both are coming, either of 1 is coming 1, okay, either this is coming this or either this is coming this, right, so we can move to the next bit. Otherwise we need to flip a bit in either A or B, right? So another case, we'll take, let's suppose we have let's suppose C and 1 is coming 0, right? So in this case, right, either A of 1 or B of 1, right, it should be equal to what, not 1, equal to 0, right, like A of 1 or B of 1, okay. So if both cases, either of the cases is coming what, 0, so if A of 1 or B of 1 is equal to 1, we need to make a one flip to make it is equal to 0, right? So therefore the number of flips that is equal to the sum of A and B and 1, right? So after each iteration, right, after each bit position, we update our answer, right? So the number of flip required in A and B, we then shift the bit of A and B and C to make it check, we are making the check to the right, right? So after shifting A to the right, A shift of 1 and A and 1, we will represent the second least significant bit, okay. So we repeat the above process until all the numbers are equal to 0 and return the answer, okay. We'll do that, okay. So let's suppose we have A, we have given what, we have given one, A is what we are making 8421, okay, this is the formula. So this is the single digit element, so we will consider this one only, okay. So 2 is means this is 1, right, so coming 1 and 0 will become, okay. For B 6, what we have to do, these two value we have to add, right, 1 1 0, right. Now what we will do, so for 0 0, right, it will become for 0 0, right, for A if we'll make A and 1, right, so what will happen, so that we have to understand, okay. So A equal to 2 is 1 0 and B is 6 equal to 1 1 0. If we'll do the sum, right, 0 0 will become what, 1 1 1 is 0, right, and this is 1, right, so this one will remain 1. Why? Because this is 5, okay. So we need to get at least if we'll do C and 1 equal to 1, we need to get at least 1 from A of 1 and B 1 of 1, right. So if we'll do the element we have given and we'll make one with the 1, and if it is equal to 1, it means it is true, right? Let me clean it a bit. Okay, so now you can see we have A we have given and B we have given, right, as per the 8421 formula, right? We can convert into binary this and this, okay, of C also. So C and 1 is 1, right? C and 1 is 1, like we have 1 0 1 we have given, and if we'll do AND with 1 means 0 0 1, and if it is coming to 1, right, which means 1 1 is 0, 0 0 is 1, and it is coming what, 1, exactly, right? 1 1, yeah, we can say 1 0 is 0, 1 0 is 0, right? Let me check. So for 1 0, okay, no, we are taking extra value, right? We have to take actually 1 0, right? With the 1 0, and we'll make 1. No, correctly, I was seeing, I was doing here, right? So it will become what, 1 1 0, no problem. Let me consider again. Okay, so C we have what, C we have 1 0 1, okay, and we are taking 1 means 0 0 1. Okay, now suppose, right, so this is our 5, this is nothing but our, let's suppose 5, and this is nothing but our 1. Okay, so once we are going to do AND operator, right, this will become what, 1 1 is become 1, right? Next what we have, 0 0 is 0, and this 1 0 is also become 0, right? And this is nothing but our 1. So this is coming true, right? This is coming true. Now suppose any of the value from either from here or here. Okay, let's do here. If we are going to do A and 1, okay, so A and 1 is 1 0 here, other what we have 0 1, and we are going to do what, AND. Okay, so 1 0 is what, 1 0 is 0, and 1 0 is 0, right? Because any of the chains if we'll do, it should be equal to 0, so this will not work. Now suppose we have 6, so 1 1 0 we have, 0 0 1 we have, right? So 0 0 is what we have here. We can consider 0 0 and 0, right, here, like this, right? Because we are taking OR operator. Okay, so in this case you can see we are getting, we need actually at least 1 from here or here. Okay, this is from coming B and 1. Okay, this is the value coming from here, so neither of this value is giving 1. Now consider this, A is 1 0, B is 1 1 1, and C is what we are coming, 1 0 1, right? So as you have seen here, if we are making this value, right, so since both A of 1 and B of 1 is coming what, 0, so we need to flip at least to one value here. Okay, so if we need to flip this value, at least one of them, then it will become what, equal. Okay, so let's suppose if I am going to flip this value here, so this will become what, 1, correct? And now we can say it is equal to the C, this one. So now B and C will become equal. So this is the second case. Now consider if A equal to 1, B equal to 3, right, we have given. So if we'll directly we will check with 0, right? We will check with the 0. So neither of these cases will come equal to, right? Because if we'll do A and 1, we know that already 1, and we have some value, what we have 1, and there is we'll take 0, let's suppose. Okay, so what will happen, we have to mark this value. If we'll do, let's suppose 1 and 1 only, so it will become 0, right? So what we have to do, it is we have to make, since both a of 1 and this is coming 1, it will come 1 only, right? So in this case, and b, if we'll take b and 1, so 3 is what, 2 and 1, so 0 1 1, right? So if we'll take 1, so it will become 0 0 1, right, like this. So in the both cases we have to take one flip because it is not matching, right? Both are coming zeros, right? So what we will have to take, we need to flip both of them and we'll make it 0, because in the last both position it is also coming 1 and it is also coming 1, right? So we have to make this 0 and this similar case, the different case you can say, okay? And if we need to get at least one of the are coming equal to 1, right, in that case we don't need to do anything because it's already giving the value. So this is the third case, right? Means first case was that at least one is coming 1, another case was there at least come, all means 0 is come, it should be, and here at least one of them should come 1. So b is already giving, so no need to require, here it's already coming, okay? So this answer is true. Now understand these three cases, right? So we are going to initialize the variable answer, which we will use to keep track of the minimum number of flips that is needed, and then we will iterate over each bit of the binary representation, that is a, b and c. Similarly, third we'll check if c and 1 is 0, we will update our answer like this. If c is equal to 1, means either 0 or 1, right, then both a and 1 both will equal to 0 and will increment our answer by 1. Now we have to shift all the numbers to the left shift, will do like this, okay? If all numbers are equal to 0, we'll return our answer, otherwise we'll repeat the steps 3 and 4, okay? So pause this video here and go through the algorithm. Algorithm is similar to that we have already discussed, right? Only the last step that we are going to do marks the shift that we have to understand, okay? So let's come to the problem here, problem answer, okay? So this is the coding sections. So let's do, we'll take one answer variable, that is 0, a not equal to 0, b not equal to 0, c not equal to 0. We will see c and 1 if it equal to 1. So either of these should happen, right? So a of 1 equal to 0, b of 1 is equal to 0. So if both are equal to 0, the second case, right, it should be equal, its answer should be incremented. Else what we have to do, answer should come from what, a and b plus b and 1. That will update our answer, right? In the final step, we will take shift of 1, shift of 2 and shift of 3, means a, b, c, right? We'll take all the shift right here with the 1 bit, and then we will finally return our answer, okay? So this is the way in which we used to do the implementation, but make sure that you have the capability to understand the example, right? And then we will understand, okay? So you have already seen, right? So what we are doing actually, we will initialize the variables, then iterate over the ABC, right? And then for each bit, right, we will see c and 1 equal to 0, we'll update our answer. If not, we'll check if it is equal to 1, both should be equal to 0, and then we'll increment by 1. Otherwise we'll make the all the numbers to the right shift, right, by 1, and if it is equal to 0, we'll return the answer. Otherwise we'll repeat the same thing again and again, okay? Now coming back to the time complexity is coming O of n, and space complexity is O of n, right? Because we are taking we are iterating over all the you can say bits of the number, right? And that's why it will take logarithmic actual values, right, of n. Now we'll understand the O of 1, because we need to update the answer. We'll modify ABC, so it will take O of 1. We are not taking extra spaces, okay? So thank you guys, thank you for watching this video. If you like this video, please hit subscribe this channel, and if you want to get the number set using a built-in function, please let me know. Otherwise thank you so much, thank you for watching this video.